So now we're moving on to the actual validation techniques. There are various types of reviews that can be helpful for requirements validation. We'll talk, for example, about commenting, inspections, walkthroughs, and a few more in varying levels of detail, but also briefly catching up on 3 supporting techniques like the perspective-based reading, prototypes, and checklists. So let's get started with the reviews, and also let's state right away that they are slightly complicated because there are a few catches and a few disadvantages that you have to keep in mind. So first of all, 90% of all companies choose testing as their own quality assurance measure. The problem is that tests require executable code. That means bugs are discovered quite late because you only have code when you already implemented requirements. And failures are discovered, not the bugs themselves. So you only experience like the behavior of the system. And not all our errors are found with testing. So testing doesn't give you a proof of correctness. And the test effort, the debugging often takes more than 50% of the development effort. So it's a very tedious and time-consuming process. So do not use reviews as your only validation technique. Also rely on other things. So still, reviews make sense. Here's a comparison of software reviews or software development without reviews and with reviews in the ideal manner. So let's say a bug has an origin in a very early stage and you only start figuring out when doing testing. So that's super late. You can see how far this timeline stretches, and usually that ends in some type of chaos, either like simple chaos or really chaotic chaos. Ideally, if you have like continuous reviews at all times, then you have a bug that is originating in the very early requirement phase, and if you already do reviews there, you might actually find the bug discover it in the requirement phase. Same goes for design, code, testing, maintenance. So you get the idea of reviewing as often as possible and as early as possible so that you can catch bugs as early as possible. There are different types of reviews. Some of them are very formal, others are less formal. So inspections being on the very formal side of things, and then in between team reviews, walkthroughs, pair programming, peer test checking, and ad hoc or commenting as the more less formal. Inspections are the most reliable review technique. There are empirical studies, and inspections find 50% more defects than, for example, walkthroughs, who are somewhere in the middle of very formal to less formal. Inspections also find up to 6 times more defects than ad hoc reviews on the very informal level. So while inspections are really good at finding and identifying defects, they are also a lot more time consuming than other techniques, and usually they are also more expensive. So instead of inspections on the completely different level of formality, you could do ad hoc reviews where you just go to a coworker and ask them spontaneously for help to find a problem. The disadvantage is that the results depend entirely on the experience of that one employee, but it's super cheap. You don't need a lot of time and effort to do that, so you could do that. Commenting is very similar. We'll come back to that in a minute in a different slide set. Peer test checking is also very similar to ad hoc reviews. The employee executes the product to be checked on paper, so mostly code, and then you see what happens and if it turns out the desired results that you're looking for. Pair programming is something that some of you might have heard before. So you take 2 developers and they share a PC or a workstation. While one operates the keyboard, the other checks the input. So one of the practices of extreme programming that are quite popular in some groups of coders. Then there are also walkthroughs, where the author of a document presents it to collaborators to gain a general understanding and improve the quality of the document. So you talk about what you did, thereby already learning something about your document, because you have to teach it and give the information in it to other people, but you also can, of course, get feedback. There's no predefined process and no guidance on how to find errors. And there's a big risk that the author easily forgets to focus on the essential parts of the document during the presentation, or that the document focus in itself might not be on point. But then, like, if someone presents it to you, you easily follow their story. So there is a little bit of a risk here. Then there are team reviews that are similar to inspections, but less formal. You just grab several employees and inspect, in each of them inspects the product individually, and the results are discussed in a meeting together with the author of the requirements document. Commenting, I already mentioned it, somewhere in the direction of ad hoc reviews or desk inspection. The author gives requirements to another person, usually a co-worker, and then receives expert opinion of the other person, which is supposed to mark flaws in the document and briefly discuss the flaws with the author. So also one of the more informal and cheaper approaches that can, depending on the co-worker, be quite fruitful or a waste of time. Then the inspection in slightly more detail. We already said it's among the best when it comes to catching defects and finding problems. And usually it consists of 4 phases. First, planning, then the overview, error detection, and error collection and consolidation. In the planning phase, you define the objective and the goals of the inspection. The roles and participants are selected. Who's going to fill which role? Who do I need to do this? And then in the overview phase, the author explains the requirements to the inspection team to get a common understanding. Then in the error detection phase, the inspectors analyze the requirements for flaws or inconsistencies or defects. They can do this either individually or in teams. And then finally, in the 4th phase, the error collection and consolidation phase, the results are collected and consolidated. Duplicate errors are removed because that could easily happen. And you check if each finding is indeed an error or something else, or maybe just a misunderstanding. Which roles are relevant? How many roles you get also depends a little bit on your budget. It would be good if you have a separate organizer who plans and supervises the inspection process. And if this organizer is separate, for example, from the moderator who leads the collection and consolidation session. The moderator should be neutral, but if you cannot get a separate person, then you might have to merge some of those roles. Then you also have the author who explains the requirements and is responsible for the error correction, while the readers introduce the requirements to be inspected and should also be neutral. Usually it's the moderator, but as I said, you can try to merge them. Please don't merge the moderator and the author because there is clearly a conflict of interest. And then one of the most important roles for the inspection is obviously the inspector or the inspectors and reviewers who are responsible for the flaw detection and to communicate their findings to the members of the project team. It is often helpful to also have someone recording or taking minutes so that you have the results during the collection and consolidation sessions right there. And it also saves the other people involved some time. So it writes the inspector or recorder, minute taker or the recorder writes protocols of the inspection results. So those are the 6 relevant roles. Some of them might be filled by the same person, but organizer, moderator and reader should not be the same as the author or the inspectors. There are different ways of how to do inspections, like very formal, as we already said, but a walkthrough could be a slightly less formal, lightweight inspection way. So it's less strict, the roles are not that strongly differentiated. So if you do not have enough time, enough workforce, or enough money, then you could decide, okay, inspection would be great, but we're going for a walkthrough. A step-by-step walkthrough of the requirements during the review sessions brings often a lot of interesting outputs. And the main idea is that the author introduces the requirements and can use the opportunity to give additional details about the requirements. For example, like the rationale for a decision, which then helps the reviewers to better understand why the requirement is there and what it was supposed to do. So those were the review techniques that we briefly touched. not in too much detail, because we want to give you an overview on each of them. There will be additional literature to look into the exact details for each of those techniques. But now we're also briefly going to touch the supporting techniques like perspective-based reading, where you validate the requirements from a certain perspective. So for example, from the user or customer perspective. Do the requirements meet the expectation and desired functions of a user? Or from a software architect perspective. Do the requirements contain all information required for the architectural design, or is there something missing? Then, for example, the tester perspective. Do the requirements contain all information necessary to derive test cases? And then content, documentation, agreement perspective, and so on and so on. So try to put on different hats and look at the problem with different perspectives. Or not at the problem, but rather at the requirements with different perspectives. Another supporting validation technique are prototypes. You implement something to try it out. Of course, not everything, because then you're already done with the final project, but rather a subset of requirements, and usually those requirements where it makes sense to build a prototype, or where you can gain a better understanding from the prototype or better validate the requirements. It should always be a throwaway prototype. Use once, throw away. Don't ever think about using the throwaway prototype or the prototype that you did for validation later in the development process. Click delete, that's it. You can also think about evolutionary prototypes that develop further after prototypical use, but this is definitely not recommended. Throw away your prototypes. The validation with prototype requires either manuals or some kind of instructions that are usually information necessary to apply the prototype in a certain scenario. And you also have to create those validation scenarios to perform some things that the prototype should fulfill. They should encompass data and user interactions so that the prototype user knows what to do. And it's also good to have a checklist with validation criteria that define how users of the prototype validate the requirements. And in best case, the results that you can get is a protocol of the auditor with experience with a prototype that they collected while using it. How did it feel? Did it work at all? Was it unclear? Something like this. You often do that with user interfaces, just to give one example there. And what is optional could be an observation protocol if you're not only having the person using the prototype, but also a second person that writes down how the auditor interacted with the prototype. Because the inside experience of the auditor might be different or look different to the outside. Maybe the person was very much involved, but for the second person outside that knows how the thing is supposed to be used, they notice a lot of things where they say, look, this was not our intention, he used it wrong or differently. So the second person can give you really interesting insights here. And then third, there are also checklists that can be quite helpful. There are a set of questions and or statements about a certain circumstance. They make sure no aspect is omitted and should not be longer than a single page. So keep those checklists short. If you have a 40-page checklist, what's the point? They can also be used in combination with all previously introduced techniques, and they provide some guidelines. They help you to structure the results, they help you to structure the process, and can make sure that you don't forget anything. The sources for the checklist entries could be the 3 quality aspects of requirements, also the requirements validation principles. You could also go back to the criteria for good requirements, or the characteristics of good requirements, the experience from prior projects, or error statistics that give you a good indication of what could go wrong or what are often sources of problems.